Hello, and thanks for joining my talk. I'm going to present on Testcontainers and API mocking for Golang projects. As we're at PlatformCon, I think many people leverage Golang for their projects on a daily basis, or maybe at least tried some, and definitely use some tools written in Golang. I'm a CNCF ambassador. I build communities, whether these are open source communities like Jenkins, Gradle, WireMock. I participated in quite a few projects, or some local communities, like, for example, Cloud Native Suisse Romand. It's a local community in the French-speaking part of Switzerland. I'm also a Testcontainers champion, and Testcontainers is the main project I'm talking about today. Everyone builds software these days, and when you build software, usually you end up maintaining it and sometimes fixing it. And if you talk about distributed environments, it actually becomes quite difficult because there are many dependencies, components, and all these components talk via different APIs. So it becomes really difficult to figure out what actually goes wrong and when it happens to fix it, debug, deploy. So we don't want to spend too much time on that after deploying to production. You totally can do a lot of things with continuous delivery, but maybe you don't want. Return back to integration tests. It's a practice that has been kind of forgotten in cloud native community for a long time, but still it's a very important thing that we should consider. Integration tests is something that we used to do, and I think it's something that we should do more often these days. I can just put on my marketing hat and say that everything gets easier with integration tests, but all of us know that it's not exactly true. Integration tests, they're quite complicated, especially when we talk about multiple technology stacks, many teams involved. There is a lot of things we do not know just in documented APIs, behaviors, or some flaky. When we talk about real infrastructure, it actually becomes even more complex. Unfortunately, integration tests are really difficult to maintain, deploy, and develop, and this is why many people, when adopting continuous delivery, try to write less integration tests. And I can totally understand it. At the same time, the mileage definitely depends on you, whether you have proper tooling, dependency framework. This is actually what defines your experience with integration tests, and this is why I'm here to talk about different developer tools. These slides are already available on my speaker deck profile, so if you miss something during the presentation, you can check it out. And there is a lot of other presentations on tools like Testcontainers, WireMock, or Gradle. I regularly present on this topic, and you can check them out. So, classic build process. Yes, we build stuff. Yes, we do unit tests and publish all the reports, and then we do integration tests. This is how it used to be, and especially for integration tests, which are heavy, we tend to parallelize them, run them only on CI, and actually it makes it even more complicated to get a result when you need it. Good news is that with modern approaches, integration tests gradually become a part of common test frameworks. We got tools that allow you to do integration tests quickly, to use the same frameworks, and it basically allows common engineers without spending too much time to implement integrating tests. This is somewhat shift left, but shift left for test automation. And there are many tools for that. Historically, integration tests were actually done in production or staging. You remember these stories when basically developer teams used to develop software, then pass to QA team that would deploy it to staging, test it, return some testing results, maybe in a few weeks, and people were already on vacation. So it was very slow. It was very difficult to maintain. At the same time, it was representing real systems. Another approach was actually mocking on the code level. So, for example, frameworks like GoMock allow doing that. You just modify the code, instrument it, and instead of talking to external service, you just run some code. This approach is very fast, but at the same time, you do not test the whole system, and you do not even test the application you are going to deploy in production because you instrumented it. There are approaches in the middle. For example, you can just mock API providers externally. So there would be a service that listens to your requests and returns some results. This is what Microcks or WireMock or other tools do. And another approach is actually having a simplified version of the destination service. it can be a full-fledged service, but normally if we speak about distributed databases, cloud-native services, they may scale quite big, and putting them in a single container or a constellation of containers isn't really possible. So for me, it's still a model. These are 4 approaches, and usually I recommend to choose between the approach 2 or approach 3, depending on your use case. And test containers is what allows to actually implement modeling of the services by putting them in a simple container. Test containers team itself says that it's real dependencies. I say it's not. It's just a model, but model based on the scale and on functionality. All the business logic should be more or less the same. Test containers, it appeared about 5 years ago, well, even more. It initially started in Java, but it got massive adoption in different technology stacks. There are implementations for all modern stacks. For example, I maintain implementation for test containers for C and C++, which is based on test containers for Golang, which is the most relevant one for the most of the audience. And test containers for Golang, the approach is very simple. In your test, you can say that you will be using a particular container, and then you say, once you define the container you want to use, you create it and then run the test as the system was there. So all the initialization of the container, all the provisioning can be handled actually by test containers as a framework. And many other things are also addressed by test containers. For example, it can suspend containers when needed, it can cache the builds, it supports various customized definitions. So despite running in the container, it can be pretty fast, sometimes even just 1 to 2 seconds to do the whole test, which addresses the biggest problem with all the integration tests. Moreover, about test containers, it has a bunch of models, which is basically SDKs for additional tools and projects like databases, external services, cloud providers, and many tools we use on a daily basis. For example, if you have Kafka, there is Apache Kafka model. If you have whatever database, there is likely to be a test containers model, because testing databases is one of the common use cases. And this actually helps you a lot, because models come not just as a wrapper that allow to simply wrap the instance and configure that, but also it includes a lot of testing capabilities like asserts, for example, that can verify the behavior of the service, or that just provide common functionality. Like if you launch a database, it needs some time to start up, or if you start a Kubernetes cluster, it also needs some time, and test containers does it transparently for you. For API mocking, there are also models. There are many services available. In test containers, you normally have Microcks, mock server, and WireMock. Today, I will be using WireMock as an example, but the same approach can be applied elsewhere. And the approach for API mocking is basically you mocking at the API provider level, like Microcks or WireMock. It's a tool that runs it, and you have still a full-fledged setup of your client application, but the external implementation is completely modeled. It can be adjusted. It can have a lot of injections, for example, to inject faults or just to record the behavior, to do contract testing. All of that can be handled by external mocking. In our case, we just write requests, receive responses like our common application would do. There are multiple solutions available on the market, whether open source and proprietary ones. Normally, I choose one of two. Either it's WireMock, which is originally written in Java, but with test containers and wrapping, it's available everywhere, including native images, and it has a rich ecosystem of extensions for various use cases. Another project you can consider, especially in the Golang ecosystem, is Microcks, because it's a CNCF project. It's implemented in Golang. It has microservice architecture out of the box, and it has top-tier test containers integrations too. Depending on your use cases, it's one or another. Recently, I started recommending Microcks more because it has support for contracts testing. It's fully driven by open standards like OpenAPI or Async API. So if you haven't checked this project, try it out. But for now, I will just show a few examples with WireMock because I have demos ready. And here's an example of a very simple test implemented for Golang. Actually, in this test, we initialize a WireMock that basically responds hello world to our request. It has its own configuration file, which we just add to the mapping. And then we can start using it. For example, here I just sent a request, processed the response, and if the response is different from what I expect, I fail. So basically, it's an integration test for WireMock model on its own, but you can connect it to your services and get this behavior. Let me show you a demo. Basically, it's what I presented before. Now, this demo is open source. You can check it out. And let's just launch it. So you can see that I just execute command, and in a few seconds, I get the result. That's it. So basically 2 seconds or so, and you get a complete test execution. And this is how a common experience with test containers would look like. And the problem with test containers is always that it's not enough, because single container is cool, but if you talk about modern projects with microservices, with distributed deployments, it's not how you can do it. Also, it's always a question about leveraging Docker for provision container, because most of current existing CI/CDs, including Argo CD, GitHub Actions, they tend to run inside containers already. Provisioning another container might be complicated, especially if you use Docker as an engine. If you use Podman, etc., it's a little bit easier, and even Docker in recent versions got this support, but still it's a question about Docker and Docker. Or maybe even Kubernetes and Kubernetes, because you also need to test Kubernetes applications, and probably you don't want to deploy to your production cluster as a part of integration test when you do some smoke tests. And for that, Test Containers also has solutions. It has solutions on multiple levels. So first of all, it's platforms. So for example, Docker and Docker or Docker Compose, it's natively supported by Test Containers via different models, and you can leverage them and provision systems within your systems. Also for Kubernetes clusters, in Golang, we have only implementation for K3s. In other stacks, for example, in Java, we also have kind, and you can basically provision the whole cluster. If you want to do machine learning or AI, you can also use tools like Ollama and other, because they also have models that basically provide you with framework and access to local models when you need to run them as a part of test. And for public clouds, there are more implementations. For AWS, you can leverage local stack as everywhere. For Google Cloud, there is also a modeling model that allows to implement some services using open source tools, and you can basically test this implementation and get something running quite quickly. And this is what I wanted to show. You can find more on the Test Containers for Golang site. It has references to many demos, models, documentation, and also there is a lot of presentations out there describing Golang maybe and the Test Containers in 15 minutes, in 3 hours. And if you want a full-fledged workshop, let me know. I'm happy to do it. You can also find the WireMock demo that I presented by following the links. And again, we have more demos for different examples as use cases that you can check out. And yeah, just a few takeaways for you. Simplify your integration testing. You can do much better with tools, and they can prevent many mistakes. And always keep in mind that all kinds of mocking, abstractions, or modeling, they're great, but they come with downsides. And obviously, you cannot do it for performance testing, etc. But when you use them right, it's a powerful tool that you can use. WireMock and Test Containers, also Microcks, they're definitely addressing the use cases. You can try them out. And actually, they work together quite well. So try out these tools. As always, contributions are welcome. All the projects are open source. You can just follow the links. There are contributor guides that you can check out. You can also participate. You can create your extensions for your tools, and it's much appreciated. If you want to learn more, I'm doing a workshop specifically on modeling AWS services with Test Containers, WireMock, and local stack. It's based on Java, so if you're a Java developer, check out this workshop. And in December, we're also doing a conference in Geneva, KZD's User Month, and be sure that there will be quite a lot of integration testing and tooling stories there. CFP opens in June, so it should be open by the time the presentation is live, and consider joining and sharing your use cases. As I said, my slides are live, check them out, and see you soon. Thanks.